Okay, guys, let's look at the second student task statement called water level in the aquarium. A large aquarium should contain 10,000 liters of water when it is filled correctly. Sorry about that, guys. It will overflow if it gets up to 12,000 liters. The fish will get sick if it gets down to 4,000 liters. The aquarium has an automatic system to help keep the correct water level. If the water level is too low, a faucet fills it. If the water level is too high, it drains open. One day, the system stopped working correctly. The faucet starts to fill the aquarium at a rate of 30 liters per minute. And the drain opens at the same time, draining the water at a rate of 20 liters per minute. Part A. Is the water level rising or falling? How do you know? Alright, guys, so before we get started, we need to do some quick annotations. Alright, so what the first sentence tells me is that the aquarium should contain 10,000 liters of water when it's filled correctly. Alright, now it says that when it overflows, it will get up to 12,000 liters before it starts overflowing. And then it's saying that this fish will get sick if it's at 4,000 liters and so on. Okay. Now, I see this in a small paragraph. It says that the aquarium the water starts to fill at 30 liters per minute, and it drains at a rate of 20 liters per minute. Okay. So, part A is asking me, is it rising or falling? All right, so what we want to do is we want to pay attention to these unit rates in part A. Okay, so the unit rate I want to first look at is filling, when the faucet starts to fill. Now, think about it, right? If I'm filling something, would that be a positive integer or a negative integer? If you guess positive, you are absolutely correct. 30 would be positive because we're adding more water to the aquarium. Okay? So then for part 2, or the second rate, it says draining. Now, think about draining. Do you think draining would be positive or negative? If you guess negative, you are absolutely correct. Now, I put 30 plus negative 20, but adding a negative is the same as subtracting a positive, which is basically the additive inverse. So 30 minus 20 is the same as saying 30 plus negative 20. Now, the reason why I wanted to subtract their unit rates is because the water is filling and draining at the same time. So we want to figure out, like, how much is it the water accumulating total. Okay, so it will be going at 10 liters per minute. I just wanted to make sure I had the right unit, so sorry about that, guys. So 10 liters per minute. Okay, and it's a positive 10. So do you think positive 10 will be rising or falling? If you guess rising, you are absolutely correct. So that's for part A. So then it says, how long will it take until the tank starts overflowing or the fish will get sick? All right. So the tank is supposed to have 10,000 liters. And then if it exceeds past 12,000, it would be considered an overflow. So what I want to do is I want to take 2,000. And where do I get that 2,000 from? I subtracted 12,000 minus 10,000, which equals 2,000. Okay? So 2,000, and I'm going to divide this by 10, which would give me 200. 200 minutes. Oops. Sorry about that. All right. All right. So let's look at the next question. It says a different aquarium should contain 15,000 liters of water when filled correctly. It will overflow if it gets to 17,600 liters. One day the aquarium is an accident. One day there is an accident and the tank cracks in 4 places. Water flows out of each crack at the rate of a half liter per hour. An emergency pump can refill the tank at a rate of 2 liters per minute. How many minutes must the pump run to replace the water lost each hour? Okay, guys, sorry about that. My computer cut off. I don't know what happened, but let's get back to the problem number 2. So let's start our annotations. So basically, the tank has 4 cracks, and like 4 cracks in different places. So it's saying that each crack has a rate of a half liter per hour. So then it says the emergency pump can refill the tank at a rate of 2 liters per minute. It says how many minutes must the tank run to replace the amount of water lost each hour. So needless to say, okay, the tank has 4 cracks, and this is like similar to the warm up we just did. So I'm going to do it how we did the warm up. Okay, so for 1 crack, it's a half liter per hour. Okay, so but the tank actually has 4 cracks. So basically we want to find the unit rate for all 4 of those cracks, okay? Or not find the unit rate, but how much water is being lost per hour, with all 4 cracks, okay? So I want to figure out, okay, well, how can I get 1 to 4? If you guess multiplying by 4 on both sides, you're absolutely correct. Because whatever you do to one side, you want to do to the other side. So I want to multiply 4 times 1/2. Make sure we put a 1 underneath that whole number. And we're going to multiply going straight across. So now I have 4 halves, or 4 divided by 2, which this simplifies to 2. So it's going to be 2 liters per hour. So this is how much water it's losing. So if it's losing that per hour, this is actually going to be a negative 2 liters per hour. Okay. So I'm going to read what the book has. It said the emergency pump is 2 liters per minute. So it must run every for 1 minute every hour to make up for what's being lost, because in 1 hour is losing 2 liters, but the pump is actually pumping 2 liters per minute. So the pump just needs to pump for 1 minute each hour to make up for what's being lost. Okay, so what we're going to do is we're going to finish going over the second half of this lesson on Monday next week. I'm going to put a different type of assignment in there for you guys to complete today. And if you have any questions about the first half of this lesson, please make sure you refer to your manager's Google Meet session. And I hope you guys enjoy your weekend. See you guys Monday. Bye, guys.